Functions. We're going to be talking about functions today, combinations and compositions of functions. Underneath are the symbols for each. For combinations of functions, we're going to add, subtract, multiply, and divide. For composition of functions, we have a new operator symbol, and it's a little circle. Sometimes you'll see composition of functions listed as f composed with g of x. And sometimes you'll see it written just like this, f of g of x. Both mean exactly the same thing. For combinations of functions, they'll be written as f plus g of x, or likewise it could have a subtraction sign in the middle of the times or a division symbol. Either one, that's how they'll be listed, and that'll be what they'll be asking you to do. They'll be asking you to add, subtract, multiply, divide, or compose two functions, or possibly more. Here are three just random functions that I chose for you. F of x equals 3x plus 1. We do need to consider the domains, so let's just look at the domains of each. The domains of f, or the domain of f, would be, well, let's see, it's a linear function, so x can be anything. So the domain for this one would be negative infinity to positive infinity. The next function, g of x, would be x squared minus 2x. That's a quadratic. And my domain, once again, is negative infinity to positive infinity. Remembering back when we talked about domains earlier, most domains are negative infinity to positive infinity. Our only little cases that we need to worry about would be if we had a denominator or underneath a square root at this particular point in time. And at this h of x function, we have that x cannot be negative 1. So x is any real number where x is not negative 1. So I can describe this as such. Union with, oops, I wrote a squarey bracket. I meant to write a roundy bracket there. Union with negative 1 on up to infinity, because x cannot be negative 1. So now I have my domains listed. Let's first do f of x plus g of x. And all that means to do is take f of x and add to it g of x, just exactly like what you think it might mean. And then combine like terms. And I'll get plus x here, plus 1. Looking at the domain of this one, because they are going to ask you for the domain of each one. The domain to begin with was negative infinity to positive infinity, and the domain at the end is also negative infinity to positive infinity. Let's find f plus g of 0. And what that means is to take your f plus g and plop in a 0 wherever there's an x. So I get 0 squared plus 0 plus 1. So f plus g of 0 is 1 in this case. So now let's look at it in another way. I'm going to do f minus h here. So I've got 3x plus 1 minus x over x plus 1. And basically I need to combine this into one term, figure out what that might end up with. That means that I will need a common denominator of x plus 1. That's just lovely. So I have 3x times x plus 1 over x plus 1 minus 1 times x plus 1 over x plus 1 minus x over x plus 1. And then this is going to equal 3x squared plus 3x minus x minus 1 minus x all over x plus 1. Combining like terms, I'll get 3x squared minus, looks like 3x minus x will just be minus x, and then a minus 1 all over x plus 1. The domain for this particular function is once again going to be negative infinity to negative 1 exclusively, union with negative 1 on up to infinity, which should be the same exact domain as h of x. Let's do a multiplication one, g of x times h of x. That will give me x squared minus 2x, and I want this whole thing to be multiplied by h, which is x over x plus 1. So I could say that this is the same as this thing over 1. Multiplying these two fractions, I will end up with x squared minus 2x quantity times x all over x plus 1. And I'm probably going to take out this other x here just so I can look at this thing, see if anything might cancel. Don't think so. But I got x minus 2, taking out that x, so I'll have x squared over x plus 1. The domain of this thing, once again, is going to be exactly what h is. It's going to be from negative infinity on up to negative 1, rounding parenthesis, on up to negative 1 to positive infinity. Since we're sitting here with this thing, let's figure out what g times h of x of 1 is. And let's plop a 1 in there all over for x, and I'll get 1 minus 2 times 1 squared all over 1 plus 1. And that's going to give me negative 1 over 2. Let's do a division problem, f divided by g. And what that means is I will take my f function, which is 3x plus 1, and put it over top of g. X squared minus 2x. I'm going to go ahead and factor that denominator, the g, so that I can read the domain off of here pretty easily. When you do your division problems, you do have to watch for the domain because you create a denominator there. So you're going to have to check to see what your domain would be. So I need to see where placing a number in for x would yield me a 0 in the denominator. Looks like my x can't be 0 and my x can't be 2. So x is any real number where x is not equal to 0 or 2. Another way to write that, which would be kind of long and tedious, but I'm going to do it anyway, would be like this. And this says anything but 0 or 2. It says exactly the same thing. Could write it either way. Sometimes they won't give you a function. Sometimes they'll give you a graph. And what you'll have to do in this case is this tells you you want f plus g. So this line right here is f, the bottom line, the top line is g, and x is 2. So I go to where x is 2. I find out what f is there. He's 1. So I write 1 plus, find out what g is there at 2. He's 2. This thing equals 3. Now they want me to do f minus g when x is 0. So I go to where x is 0. He's right here along this y-axis. And x at 0 is, f is negative 1. Minus, and g is 0 there. So this equals negative 1. This wants me to do f times g when x is 2. So I look at f when x is 2, and it is 1. Times, and when x is 2, g is 2. So this answer would be 2. And that's what you do when you are given a graph and asked to do a combination of functions. We're going to do composition of functions next. How you would say this would be f composed with g of x. Means exactly the same thing as this particular function right here. So what I'm going to do is I'm going to look at f. He's my main function, 3 times x plus 1. But what we have is that this thing right here is what my x would be. So my x, which I did have 3 times x plus 1, my x is actually g. And he's what's inside. So I write x squared minus 2x, where there would be an x. And then the next thing that I would do would be just to simplify. So this would yield 3x squared minus 6x plus 1. They're going to have you check domains on some of these as well. And you'll just follow your standard domain rules. Just look at this particular function. He's a quadratic, so my domain on this would be from negative infinity to positive infinity. Let's look at g composed with f, because this is something very interesting about composition of functions. When I do g composed with f, I would yield, I need my g function, he's my main function, x squared minus 2 times whatever x is. But in this case, I'm replacing my x with f. So inside of here, I'll put 3x plus 1, 3x plus 1. Wherever there was an x, I put a 3x plus 1. I'll do my simplifying, and I've got to multiply out 3x plus 1 times 3x plus 1. So I'm going to get 9x squared plus 6x plus 1 minus 6x minus 2. And still simplifying, I get 9x squared. Looks like I'll get just minus 1. And that's it. I need for you to notice that composition of functions is not commutative, meaning that f of g is definitely not the same thing as g of f. Let's look at f of h. So my main function is f, 3 times x plus 1. In place of x, I'll put h. So I've got x over x plus 1. And then it's just a matter of simplifying. So I'll have 3x over x plus 1. I'll need to combine this, so let me get a common denominator. This will be x plus 1 over x plus 1. Keep the same denominator and add the tops. And I'll get 4x plus 1. That's f of h. The domain on that particular function would be the same as the domain for h. So let's do h of f. Now this function looks like h, but in place of x, I'm going to write whatever f is. So I'll go in here, get my new color. Let's see, I've got to replace that with f, 3x plus 1. This x I replace with f, 3x plus 1. And simplifying yields 3x plus 1 over, looks like 3x plus 2. Alright, now the domain on this is not the same as h. The domain on this, my x cannot be where x is any real number and x is not equal to negative 2/3. That would be the domain on h of f. Notice these two things, once again, are not the same, showing you that the composition of functions is not commutative. Alright, let's do f of g of 1. Remember that this also represents f of g of 1. Might be a little easier to look at. Go deep inside. Let's go find g of 1. So g of 1, when x is 1, g is 2. So now you're going to find f of 2, and f of 2 when x is 2, f is 1, so this equals 1. So it equals 1. Let's do g of f of 1. So we're going to find f of 1 first. F of 1 is negative 1. So I need to find g of negative 1. Go to where x is negative 1, and g is 1 there. Now, function composition is not commutative, but in this particular case, they ended up the same, but that was coincidence and nothing more. And that's how you use a graph to do function composition.